Hey everyone. All right, so this is the start of our new unit. We're going to talk about graphing and parent functions, and we're going to talk about each one. So the first one we're going to talk about is linear. The parent function for this guy is just y equals x. So our slope is 1 and our y-intercept is 0. So that means when we plot our points for the graph, we should be going up and over 1 unit. So we can make this straight line. This is the parent function. So this is like the original basic function. So for linear, the domain, if you recall from our unit, was all real numbers, negative infinity to positive infinity. And the range is also the same thing, negative infinity to positive infinity. All right. So that's linear. We just finished our quadratic unit. Our parent function for quadratics is y equals x squared. So we would use our table, our t-table, to help get our points. We know that our axis of symmetry here, opposite b over 2a. If we did all that, we would get a vertex of 0, 0, and that's also our y-intercept. And so anytime we plug in a number, we should get a positive number out of it, and it should be symmetrical across that axis of symmetry. So I'm not going to review all that stuff with you because we just did that unit. But that is what the parent function looks like. And so when we did domain and range, we also said that domain was all real numbers, and then range was wherever, from down to up, wherever you start, finish, or finish and start, where you're coming from. So here we're starting at 0 and we're going all the way to positive infinity. And so that's the one that will change depending on how you move it. So that's linear and quadratic. Cubic is, we haven't really done a lot with it. It's the parent function is y equals x to the third. Again, it has a main vertex, a main point at 0, 0. And if you plugged in numbers to your function to figure out what you could plug in, so here if we plug in -1, 0, and 1, we know what 0, 0 is. -1 cubed is just -1. Positive 1 cubed is 1. So it has this, this shape. 1, 2, 3, 4, 5, 6, 7, 8. I'm just trying to make sure it's accurate. 1, 2, 3, 4, 5, 6, 7, 8. It's got this kind of a squiggle shape, but it goes through 0, 0, and that's the main point for that. But these three you could use to help you graph. So your domain is all real numbers, and your range is also all real numbers. Okay, so that one's pretty straightforward right there. So moving from cubic, we're going to do absolute value. So absolute value, your parent function has the absolute value symbol with the x inside. And this is similar to a quadratic function, but it has a different shape. So its vertex is also on 0, 0. If you plugged in 0, you would get 0 out. If you plug in 1, you would get a positive 1 out. If you plug in 2, you would get a positive 2 out. So if you remember, absolute value changes negative items inside to positive. So if we plug in -1, we should get a positive 1. If we plug in -2, we should get a positive 2. And that pattern continues all the way through on both sides. So you have this, instead of a parabola, you have this V. Instead of the U shape, the absolute value gives you a V. So domain for this is just all real numbers, so negative infinity to positive infinity. And your range, we're including 0, and we only get positive answers, so we'll go to positive infinity. All right, so that's our first row of functions. So absolute value, cubic, quadratic, and linear. Okay, and then we have another row below that we're going to talk about. So we need to discuss a few more. So square root, what that parent function looks like is just y equals, and then you have just x inside the square root. Okay, this is a little bit different because at this point we do not take square roots of negative numbers, so we're not going to put in -1, we're not going to put in -2. Depending on what your function looks like, you can plug in negative numbers, but we're not doing that with our parent function. So if we plug in 0, the square root of 0 is 0. If we plug in 1, square root of 1 is 1. And so for our inputs, I'm going to take perfect squares because I get nice, pretty answers. So I can plot some points. So I can start at 0. Plot my point 0, 0, 1, 1. So then 1, 2, 3, 4, up 2. And then 9, I'm not going to do because it'll roll into my other graph. But it has this shape to it. Okay. So your domain here is going to be from 0 to positive infinity. And your range will also give you that same interval. Okay. So square root, depending on what it looks like, the domain and range will change, but for your parent function, this is what that looks like. Domain and range are 0 to positive infinity. All right, so we talked about exponential functions this year. So we have our standard parent function here is some base with x to the exponent, but we have that, a out front. So a times b to the x, and that's kind of your standard. For exponentials, there's only really one point you need to really be concerned about, and that's your y-intercept. Okay, that's something that we call an anchor point, and we referenced this during our unit, but we didn't do a lot with it, but this is called an anchor point. It's the only point that's consistent in every single exponential function. So when you have the parent function, it's going to go through that, but also any other exponential function you have will also be there because of x here, x is 0, which means it turns any base here into 1. So depending on what a is, it could change, but that's your standard. So then your domain, we are not including 0. So this is a little bit more than what you need, but there's like an invisible line that this does not cross. So we don't include 0 in our domain. So it's 0 to positive infinity. And that's the same. And that's the same for your range. So your exponential function will never cross the x-axis. It just won't do that. So make sure that you have parentheses there instead of brackets. So there's something called a rational function, and what that equation looks like is y equals 1 over x. And we'll make it not glitchy. So y equals 1 over x. So for this, it's called a rational function because this is a fraction. And fractions are also referred to as rational numbers. So that's why it's called a rational function. It's not called a fraction function, it's called a rational function. So you have this fun looking graph, and it's hard to get it exact, but it's basically two curves in, oops, if I can draw it correctly, it's these two curves that will be in quadrant 1 and quadrant 3. And they don't cross your x-axis, they don't cross your y-axis. So your domain for this is going to be, if you remember that union symbol, it's going to be negative infinity to 0 and then 0 to infinity. Your x value in your parent function cannot equal 0 in the bottom. So when we talked about fractions, if we had a fraction of 1 over 0, you would tell me that that was undefined. You would get an error. So that's why your domain has to not include 0, because we can't have an undefined number in our domain. We're not including that number. So that also means that your range will be the same, because if you can't get 0 as a result, okay, if you can't get 0 as a result, then we also have to include that in our range. So that's rational. All right, so that's rational. So now we're going to look at logarithmic. These are things that you're going to see later. I just think it's important that you kind of are familiar with what that graph looks like. So logarithmic, it's not super crucial that we talk about it, but you have y equals some log base, so b of x. So really what this looks like is, again, you have a function. That's not the right point. It's right here. You have this function, and this will get really close to the y-axis. It also has an anchor point. This anchor point is at 1, 0. And again, this is more for future classes. You have this anchor point at 1, 0, and that's the only point that we're really concerned with, because logs are used in various topics. They're used mainly in sciences, and the calculations are very complex. So for the graph, what you need to know is that your domain is from 0 to positive infinity, not including 0, and the range is the same thing. All right, that's really what you need to know for those two. And so that is that row of functions. All right, so these are all the main functions that you're going to see. There's a function we did not talk about that you're going to see in A2. I'm just going to leave that for Mr. Zimmer to do with you. But if you have any questions about these, come to office hours. But make sure that you are familiar with absolute value and square root. We just did quadratics and we've done linears. So the next two that you really need to be familiar with are absolute value and square root. We also did exponential. I can't forget that guy. All right, have a good day.